if I wanted to subtract two-thirds and 10 over 11, the first thing I need to do is I need to find the LCD, where dem 1 is 3 and dem 2 is 11. And since 3 and 11 don't have anything in common, the LCD is going to be 3 times 11, or 33. So that says in order for me to count 2/3 and 10/11, I have to make them 33rds, because that means the size of the pieces are the same. So what would I do? I turn 2/3. Well, what is it missing? Well, if I take the 3, it's missing an 11. So I take 2/3 and I would multiply by 11 over 11. That's going to give me 22 33rds. Then if I take a look at 11, what it's missing is a 3. I take 10 over 11 and multiply by 3 over 3. That makes that 30 33rds. So that these are equivalent fractions. It would be as though I would say, you know, I would like to turn 1/2 into sixths. In order to make it a sixth, I'd have to multiply by 3 over 3, 3 over 6, and we notice that 3 over 6 is another name for 1/2. So now I have my new names. 2/3 is the equivalent of 22 33rds. Subtract 10 11ths. 10 11ths is the equivalent of 30 33rds. If the denominators are the same, I'm now counting 33rds. How many 33rds do I have? I have 22 minus 30 of them, or negative 8 33rds. It's a much longer process. Okay, so here we go. Step 1 is to find the LCD between 15 and 36. Well, we know that 15 is 3 times 5. That's easy. 36 is going to take some work for me. Now 36 is even, so this is 2 times 18, and 2 divides 18 9 times, 3 divides 9 3 times. It's 2 times 2 times 3 times 3, however that you would like to do that. So the LCD would be a combination of those two numbers. It must have a 3 and a 5 in it, so that's 15. It must have 2 2s, which it doesn't have. It must have 2 3s. I already have 1 3. It needs another 3. So I can see that 36 is in it. I can also see that 15 is in it. That's the smallest. And this is going to be, what, 10 times 9 and 2 is 18. Looks like it's going to be 10 times 18, which is 180. So that's what the LCD is. So that says I need to turn 15 into 180, turn 36 into 180, so I can count them. Now, if I look at 15, 15 is 3 times 5. What I would need would be 2 2s and 1 3. That's 4 times 3. 4 times 3 is 12. So that says I multiply this guy by 12 over 12. That turns this into 180. So now that's your LCD. And then 36. 36 is 2 2s and 2 3s. Well, that's the red part. If I take 2 2s, 1 3, second 3, it's missing a 5. Numbers are harder, by the way. So I multiply by 5 over 5. This is 180. So 12 times 2, that's 24 over 180. plus 5 times 5 is 25 over 180. So this becomes 24 plus 25 over 180. Since the denominators are the same, I can now count how many pieces of 180 size do I have, which turns into 49 over 180. Now at this point, step 4 says reduce the fraction, but in this case, this guy is 7 times 7. There ain't a 7 in 180. Now you say, well, how do I know there's not a 7 in 180? 180 is 3 times 5 times 2 times 2 times 3. No 7s. And 49 can only be 49 and 1 and 7 and 7. So this is prime. Now what I didn't do here that I should have done, which I'll do in the next hour, is literally, it says write each fraction, is where you would take 2 over 15, and then you would turn that into something over 180 by essentially multiplying by 12 over 12. Then this becomes 180, and that's 24. And that's where 24 over 180 came from. And then you would take 5 over 36, and then multiply it by 5 over 5. So that's the 25 over 180. So this is this guy, and then you add the 2. So algebra works just like arithmetic. The only difference is instead of having numbers, you have variables, and the variables make life nicer than numbers do.